Yeah, we'd love to talk to you guys about what we do at Avidbots. So just a quick agenda for what we'll be talking about today is we'll do an introduction about Avidbots, then we'll talk about AI and machine learning at Avidbots, then go a bit deeper into some of the challenges that we run into in perception, and then talk a little bit about obstacle detection using deep learning, similar to some of the things that James was talking about actually. And then, yeah, what's next and some time for Q&A. Cool. Yeah, hopefully the video plays. Yeah. Can you mute it, Yoohee? There you go. Okay. Yeah. Sorry.
I can mute it. I can.
That's our actual. Yeah. Anyway, so this is basically a quick video of our robot. This is what we do. Avidbots, we design and manufacture Nia 2. This is basically the world's best self-driving storage scrubber. So what it is basically a bigger version of a Roomba. So it's a robot that cleans commercial spaces like airports and warehouses, that kind of thing. The main thing, of course, is that we are the world leader in terms of navigation, how our robot dynamically adapts to the facility. As you can imagine, in the real world, spaces are constantly changing. And so, our robot is currently capable of adapting to that. Also, we see Neo as like a platform. As you guys are watching here, there's the robot has a disinfection system that can also be attached to the machine to provide more value. So this is certainly, again, we're a robotics company first, certainly very focused on cleaning, which is a very challenging problem, but also we do see it as a platform and also what we can potentially do in the future. So yeah, you can go to the next slide. Yeah, so just to talk about our vision of our company, to bring robotic solutions into the real world, to increase organizational productivity, and to do that better than any other company in the world. That's the vision that we're at, and really the focus is around the solution, so the robots and also solutions around the robots, and to truly increase the productivity of our customers. Just continuing on, basically about kind of some of the numbers about Avidbots, and just to give you guys an idea of our company and our deployments. So we have over 300 robots deployed running in the real world day to day. We have cleaned over 1.5 billion square feet. That's quite a bit of space. There's no numbers here, but I was doing the math, and I think we've saved over 120 years of labor of like humans actually pushing machines by hand with the fleet so far. And again, this is all exponential, so it's gonna grow exponentially as the robots continue to clean. Many of our customers, 27% of them expand. So they buy one scrubber, they like it, and then they start replacing their fleets, which is really exciting. We grow basically 100% year over year. A really good metric as well. We already have over 100 customers across 5 continents. And this is kind of a bit of the capital we have raised so far. So yeah, certainly a growing scale up. We're about 170 people worldwide, just to give you guys an idea. So if you go to the next slide, you can. So I guess to talk a bit more about the interesting sections, so certainly AI and machine learning play a big role at Avidbots. One of the key differentiators of our product and why it's really the leading product out there for this kind of applications is our approach at how the machine cleans. So our robot is actually it uses the Avidbots AI platform. So it's truly an adaptive robot. So it first maps your facility, and then it plans the paths dynamically for every single night. So a lot of our competitors have other kind of approaches like teach and repeat or other sort of manual approaches. But our goal here is to truly allow our customers to just press play and then leave the machine to be capable of covering the space and clean it. So there's of course many technologies that we need to leverage, certainly localization and perception, and we need to also do this all reliably. So that's really where AI comes, and then Yoohee is going to talk a bit more about how we are actually using machine learning, particularly deep learning and semantic segmentation, to do some of these things. And I guess to maybe give you guys another idea is we are also deployed in quite a bit of different verticals. So we are deployed in airports and shopping malls, warehouses. We're entering the retail market as well, like grocery stores, that kind of thing. So we're running into a number of very complex perception issues because as you can imagine, the real world is messy and there's issues. So Yoohee will dive a bit deeper into that.
Sure. Thank you, Pablo. So what are the challenges do we have in perception world? Well, more specifically in obstacle detection. So the real world, it can be really, really messy. So the image on the right is not an exaggerated version of the real world. If you go to a hardware store and you often find like some wooden blocks or pieces that kind of like sticks out, or chains or cables on the floor. So how do we design a robot that can navigate safely around these obstacles while trying to maximize the area that it can clean? Detecting the free space accurately is highly dependent on the quality of the data that you get from the sensors. And, but the sensor is not always perfect. So small objects like cables, chains, phones, or like thin chair legs, and these objects are all around us. It can be found in our everyday life, and they can be pretty challenging to be detected with highly reflected, with the currently available and affordable sensors in the market. So not to mention, the world can be very dynamic. The real world is not static. It's constantly changing. So it's very difficult to predict all possible scenarios and problems that can occur. So how do we address these challenges? The idea is to use deep learning to help with some of these challenges that I've mentioned. Deep learning has been getting a lot of attention lately, and it's a fast-moving space. Obstacle detection is a great application for deep learning, as most of the state-of-the-art computer vision tasks are now based on the deep learning approaches. So we are using semantic segmentation to address some of the challenges I've mentioned. So what is semantic segmentation? Right? Semantic segmentation is a supervised deep learning approach for a computer vision classification task. And the goal of semantic segmentation is to label each pixel of an image with a corresponding class of what does it really represent. So, okay, so what does that really mean? We're basically predicting every pixel in the image. Does this pixel belong to an empty space, or does this pixel belong to an object? So if you take a look at the pictures on the right, it basically classifies each pixel to a number of classes defined for the problem. So the top pictures are overlaid image that have segmentation outputs overlaid on top of the original images. The dark region represents free space, and the lighter region represents occupied space. This is a binary classification problem where it's either free or occupied. And the bottom images, on the other hand, have like more than two classes. So objective here is not only just to recognize the object on the floor, but also to delineate the boundaries of each object, so we know exactly where the boundaries are in the space, so we can kind of plan paths to navigate around these objects. So this is the difference between object detection task and a semantic segmentation task. So, the output that we get from object detection algorithms, a bounding box of an object, is really not good enough for our applications. We need to know exact boundaries of all objects on the floor. So this is why we chose semantic segmentation over object detection algorithms. So as you can see in the video right here on the right, semantic segmentation is useful for like variety of applications, self-driving cars, even in medical image diagnosis. So these deep learning approaches have been proven in many different applications, including ours. And it can really help us to address some of the issues that I've mentioned in the previous slides. So what are the next steps in the obstacle detection project? So I wish I could say there's nothing, we pretty much address all the issues and it's all good to go. But no, that's not it. It's just the beginning. So there are many things we can do to improve the current work. One, expand verticals. We have started this project, focusing more on like a warehouse verticals, but now I think it's time to move on to other verticals like retails or different types of facilities, just like what Pablo said. In technical words, what it means is that the current model has been trained with objects that are more likely to be seen in warehouse spaces, with objects like forklifts, tools, stools, stations, and things like that. We can explore different options to expand this model to work in other verticals like hospitals, airports or grocery stores and so on. So these places are more likely to have different types of objects than the ones that we trained with. So how do we go about this? One way, I think, is to have one generic model that can work in all different types of environments. We can have like one generic model. Or another way is to have different models for different verticals. So we can kind of keep each model relatively light. Having one generic model, I think it can be very computationally expensive, and it will be very difficult to avoid introducing like bias in the data. You don't want to have too much data coming from just one of the verticals. Okay. 2, scale it. It's really important to pay attention to performance at scale. Once we deploy these features, we're probably likely to have to support this model so it can handle some of the objects that maybe wasn't available in the training data set. So this could mean that we need an upgrade in the entire data pipeline. We need to improve our data collection tools to automatically trigger data collection to capture images. And we need a fully automated pre-processing pipeline. Should be able to kind of like clean up the data to fit our needs. So we don't have to like manually go through a large amount of data. It would be quite painful to do this manually. So annotation tool is another part where we need a lot of improvement. There's been a lot of work done on the data annotation topic in academia since we looked at it. So I think in each layer of the data pipeline that I talked about, we can integrate a machine learning solution to further improve the current existing work. 3, better scene understanding. So the world is just more than just a binary, drivable space and non-drivable space. So the binary class semantic segmentation can be extended to multi-class. Then we can gain better understanding of the scene without applying too much effort, given what we have. So how do we humans perceive the world? Let's think about this. It's definitely more than binary. We don't perceive the world as, oh, this space I can walk, oh, this space I can't, right? So that's sort of what we need to try to achieve on the robots. We can classify areas. So say like if it's too dangerous for the robot to get too close to, for instance, like staircases or escalators, then we can kind of classify as a separate class. We can also classify dynamic obstacles separate, so we can give extra space when the robot is navigating around them, in case the obstacle decided to suddenly move. Having a better understanding of the robot's surrounding can definitely help the robots to behave smarter and more socially acceptable, just like humans. And 4, never stop learning. So this is kind of like my motto. I believe that there's no end for learning. Semantic segmentation has gained a lot of traction in the past few years, and there are new architectures getting researched and developed as we speak. So I think it's very important that we kind of keep up with the new technologies and look out for the new algorithms that are out there and see if it can apply to our applications. If any of you guys were interested by all the stuff that I talked about, all the future work, and if you're just like me who never stop learning, then please reach out to me or Pablo, and we would be happy to have a chat with you.
Yoohee, tell us a little bit about Waterloo-trons. That sounds cool. What's that about?
Yes, actually, both Pablo and I are from Waterloo. We study mechatronics. Mm-hmm. So mechatronics is basically a combination of electrical, software, and mechanical. So basically, it's a robot, right? And that's what we studied at University of Waterloo. It's a really cool topic. And basically, the work that I do at Avidbots is a pure Tron. So I'm very proud to be part of Avidbots.
So in Waterloo-trons is like a little, like kind of a study group institution within Waterloo University or something, or?
Okay, no, it's a program. It's just like another type of engineering.
I see.
Tron is the short for mechatronics. Megatron.
Ah, right. Okay, cool.
One thing is just, if I may, it's kind of it because it's interesting. Since we were talking earlier about the mecha robotics in Waterloo, I just wanted to let you know, like the co-founders of ClearPad and a lot of the early people are also from mechatronics engineering.
There you go. James says he's also a Tron.
And James is also a Tron from mechatronics.
Way to go.
So again, and also to give you an idea, like Arian Labs is actually started by somebody who was in the robotics team.
Mhm.
And again, Ryan Garapy from ClearPad, myself, James was also part of the robotics team. So all the robotics team people eventually went and I guess started companies in this. So it's definitely, there's the roots of the companies in which we're with.
That's awesome. That's what I want to see, like kind of tech, grassroots, community building, all about that. And what was that drone company you said before, Pablo? That was
Arian Labs.
do you want to put that in the chat section? I'd be keen to hit them up maybe about our
Sure.
next event. Let's jump to a couple of questions now. Siddharth said, "Hi, I wanted to ask what is a semantic segmentation algorithm you were using? Are there any specific algorithms for obstacle detection other than general research like UNet or MaskR CNN?"
I can take this. It's basically a variation of UNet. It's a pretty simple semantic segmentations that's adapted to our applications. So I don't think it's something that you can find in another paper. We kind of like took whatever was out there and then we, changed it, modified it so that it can better perform with our application.
Awesome. Andrew has asked, are Avidbot robots capable of operating in a dynamic environment where working humans are present, for example?
Yeah, maybe I can answer that one. So yes, this is an interesting topic, as James and Jay were saying. So the basically the out there, basically the standards are getting developed. In fact, actually, Avidbots, we are one of the first companies to start probably what will become actually the first IEC Type C standard for robots in the real world. So again, this is all just happening. There's no standards, nothing is written. So yes, the answer to your question is yes. Our robots have a our controller is able to estimate. Basically, it produces a large sound and it slows down accordingly. So it is. There's certainly we can improve it as well. We can make full-blown dynamic obstacle avoidance and prediction of motion. We don't do that yet, but it's good enough as it is. We operate in many airports when a lot of people come out. And again, we do have we're pretty good when compared to our competition in terms of how the robots react to highly dynamic places. And this is where we were saying it's very challenging, but you can imagine a lot of people and you're trying to localize an environment that's changing drastically because there's all this legs of these people now changing the area. So it is certainly challenging, but we do operate. But again, it's something that is going to keep growing. You will see in the next 3 to 5 years more standards getting released that discuss safety around these things, because again, it is the interest of the entire industry to put robots to the service of people and really do this safely, because it's very important the robots are seen as companions and tools and not something that can harm people in any way.
There are some tricks and approaches to avoiding using segmentations, as it needs many annotated data points, and as data gets bigger and more computing power is required. Have other approaches been explored?
I can take this. Yes, we have explored other approaches, but so basically we decided to go with semantic segmentation is because you did mention annotation, right? With UNet or its variant, the benefit of using it is because we don't really need a huge amount of annotation data. Like the performance you get from using this types of semantic segmentation is surprisingly really good. Like I've read some of the papers from that comes from a medical background, and they use UNet type semantic segmentations, and basically they had like 100 annotation data, and that it was still able to identify where are the cancers or where are the anomalies in the images. So it was really cool. So yeah, to answer your questions, we chose semantic segmentation, especially a UNet variant, is because of that reason. It doesn't rely on a huge annotation data. And plus, I think we made some changes so that the computing power isn't going to be a problem for us.
Way to go.
I may add a little bit to this just to give you an overall picture. Like, so I guess one of the main reasons too is like, we have explored every trick in the book. Like we have tried like 5 different algorithms. We did like a radial one, then we did like multi-frame tracking. we did all these things. But it's important to note is that the sensors that we're using need to be calibrated, and sometimes they're not perfectly calibrated, so there's some noise there. That's one. Two, the sensor itself is the sensors we use are these stereo sensors, so they have some noise sometimes when there's this sunlight and things. So you cannot lower the detection threshold right to the floor, because then again, your calibration is going to matter. Then if there's noise and reflectivity in the floor, that's going to matter, and it's going to throw off, and the robots are going to get stuck. And so to give you an idea too, like one big application of why we're doing this is detecting the forks of the forklift. So those things are like right to the floor, and they're like 5 centimeters, and they're very reflective. It's like a nightmare. And so again, humans are so good, right? We just look at it, we're like, yeah, well, I'm not gonna run into the forks of the forklift, because this is a fork of the forklift. But a robot is like gathering all this 3D data, and it's like, yeah, okay, but that's a forklift, I can see that. But then the forks, it thinks it's noise, it thinks it's the floor. So then it hits it, and then it's not good. And so yeah, this is really the purpose of semantic segmentation, is to do things like cables, stanchions, things that humans have a really natural way to be like, yeah, contextual understanding. So we get it that it's an obstacle, but robots don't, and they're very skinny, it's hard to, very, very, things that are very difficult to detect. That's why we're using semantic segmentation.
When you first expose your robots to a new scenery, do you use any techniques in unsupervised learning? If so, please elaborate.
No, we don't. I guess that would be a short answer to your questions. Currently, we don't. Right now, this supervised method of using semantic segmentation is what we have and what we are planning on expanding. So going forward, I've actually came across a lot of papers that do unsupervised learning and semi-supervised learning. As annotation gets tough, and lack of data. And as we go, we cannot possibly have a collection of data that represents a whole world. There's gonna be new objects, and there's gonna be new obstacles that we'll face. So I think eventually we would have to look into those options.
Do you train on your own data sets or used pre-trained models?
We train on our own data sets.
Cool. Short and sweet. Lou has
One
asked,
little thing to add, maybe just to let you guys give an idea. We also do use like simulation. So we have this like 3D environment that we simulate these obstacles we were talking about. That we have a forklift, and we have like a stanchion and whatever, and we run this basically data, and it's already annotated. So the simulator would output something that's pre-annotated. That's very helpful to get the ball rolling, because it's very expensive to gather real data, right? To annotate by hand and be like, that's a forklift, and you annotate the forks and you annotate all the details. It takes a long time. So yeah, we also use simulation. And that's an important, this is a fundamental for machine learning.
Right.
Especially when you want to deploy in the real world. You certainly cannot just do it with just raw data. You will need a lot of data, and it will be very painful, and it will take forever.
Yeah, the simulation data that we have, it's really cool, because you can change like the lightings and the floor types and everything. So you get a full control. I mean, sure, it's not generalized to an extent, but it still does a pretty good job.
Awesome. Lou has asked, you've mentioned that AI is used for object detection and navigation. However, as the robot navigates the facility, does the robot detect dirty spots or areas within the facility in real time and historically, with the intent to adjust the application of the cleaning solutions? That's an interesting in-depth question.
Very nice. Pablo, you want to take that?
Yeah, sure. That's a very good point. Very valid. We've talked about that, and we have our beer time on Fridays, where we just like talk about stuff and ideas about the future. So yeah, this has come up many times. We've actually kind of looked into it a little bit, very briefly. It is actually very, very complicated. Detecting dirtiness it's easy to say, but there's many vectors to something being dirty. Certainly one is the visual inspection, but yeah, there's also a lot to be said about bacterial content and things like that. And then, even if it looks clean, it might not be clean. And even if it looks dirty, it might not actually be dirty. So yeah, there's quite a bit there. I know that some other of our competitors started looking into it. It's just a very hard problem. That's what I just want to say right off the bat. So we haven't really looked into it again, as maybe James was saying, and Jay, even just doing the basics of what we are doing. And again, maybe this sounds a bit boring. And I know you guys are like making the robots and I think Disney and the real world, Disney and just the popular culture makes robotics, sound very simple, and it's actually very hard to do a lot of the things that we're doing. And just getting it to clean a grocery store reliably and all the time and properly is actually quite a bit of work. So yeah, I would say we're still solving the basic problems. I guess the second comment you wrote there about adjusting data, you might want to take a look. So iRobot actually has with their latest robot, they have an app that actually does that. It actually cleans your facility. They have a particle counter, and then they're actually able to use AI to clean certain areas more often than they should be. And then the iRobot actually suggests how you should clean. So yeah, that's pretty neat. And that's something. Again, we're at this point very focused on nailing the basics and really, owning all those verticals that we're going at and expanding. Really, that's really the goal. I mean, cleaning, give you guys an idea, like right now it's probably like 2-3% automated. We want it to be 30% in the next 5 years, right? So that would be success. Can we literally do 30% of the cleaning that's done today? Can it be done autonomously? And just that on itself, it's a lot.
It's a
To
huge
cover.
challenge.
It's very hard. I know it sounds boring. I know it is. I know it's boring, but it's that's the thing. You watch Wally. I feel like terrible. Like this guy's Wally, like the small robot, the little guy that detects dirt and goes and cleans it. Oh my god! It's like I watch this and I'm just like I will be dead and we won't be there. Like to be that awesome, to be that incredibly cool as what they drew it. Probably not even in our lifetime. But anyway, we're working towards it.
Yeah. Like somebody said, "Oh, this is like really simple. Like it might be simple, but it's really complicated." And then somebody else is like, "Oh, you might think this is boring." I don't think anybody here thinks that this is A, boring, or B, simple. I think this is very complex, awesome stuff that you guys are doing. A good solution. Is this being deployed or piloted anywhere?
Yeah, we have basically we've deployed, just to be, I guess, the number, over 300 robots deployed. We have more than 100 locations. It's quite even in Toronto, I guess we're in Eaton Center. We clean Eaton Center in the morning.
Cool.
So if you wanted to snap a picture of it, it's going to runs there every day. There's Yorkdale Mall, by the way, guys. I don't know if you guys know, but I'm sure you know Yorkdale Mall is the best customer of Avidbots. We love them so much. They was the first robot. We have a robot there. If you ever go there overnight, that robot is the first robot number 3 we ever built and still running. It runs every night. It cleans 6 hours. It's really our kind of our pride and joy, that robot. And so we are cleaning, we are deployed, and we can show you some sites. There's quite a few in Toronto.
If you haven't already, why don't you make Neo modular and allow it to have other attachments for added functionality while benefiting from the autonomous navigation stack that's already working well? Question mark.
Oh yeah, that's right. Actually, you saw, maybe you missed it, but at the beginning in the video, we actually are doing that, and you're totally right. That's really, I think we see ourselves as Avidbots as one of ideally the people kind of pushing this multi-application robotics. So absolutely, it's very close to our vision to expand basically the productivity of our customers. So we are going to be releasing very soon. Most likely you will see it coming out next year, early next year. We have a disinfection add-on. So we basically have put a chemical disinfection system in Neo, and then Neo is going to clean. And then after it's done cleaning, so let's talk about Yorkdale Mall. It's going to go to the benches, and it's going to go to the doors, and it's going to spray a chemical disinfectant. Because right now, actually, just so you guys know, cleaning teams are now spending between 15 and 20 hours every week just to basically disinfect. They actually go and disinfect your handles, disinfect the benches. So it's just a lot, actually. It's actually some people are now not cleaning the floor because they are doing so much disinfection. So yeah, we're starting with disinfection, but there's many other applications like security and others. And so yeah, absolutely, Neo is that we see it as a platform that can truly expand. And we designed it with that in mind. The top compartment is extensible. We have APIs. We have mechanical mounting points, electrical systems. So absolutely, it's a robot. It's not just a floor cleaning machine.
Yeah, way to go. Will they ever be able to detect low-lying objects under 15 centimeters one day?
I think we are already. Yeah, with the semantic segmentation approach that I presented today, yeah, we are definitely being able to detect all those small obstacles that I mentioned that were challenging initially, those cables and wires and very small objects on the floor. Yeah, with the new stack, using deep learning, we were able to detect all of that.
Cool. AJ has asked, is the robot designed for single floor facility or can it be extended for a multi-floor facility as well?
Yeah, that's a good question. So yeah, Neo is, again, the beginning, we're making it very, it's a floor scrubber, so it is for hard floor. We are planning to release in the future, in a few years actually, not anytime soon, but certainly in our roadmap, to make basically like a vacuum cleaner robot. That this vacuum cleaner, we could design it in a way that could also be a sweeper, so it could also then sweep the floor. So it would work on both hard and carpet. But yeah, at this point, we're very focused on hard floor. There's quite a bit of that in many facilities, so we need to nail that one first. But yeah, certainly we do want to make capable of doing cleaning in multi-floor types.
Very good. And Lou, does the robot ever take a break and have a beer?
Oh,
It doesn't have arms. How's it going to drink?
You guys are joking, but we were about to make a beer dispensing robot in one of our hackathons. We didn't finish it, but we started it. There's a prototype of a robot that has like a. Anyway, we want to do it really for this fundraisers that we do. We do this fundraisers yearly. We couldn't do it because of COVID, but we do this music event. We want to have the robots run around dispensing beer.